What's up guys, it's Timon Fiaz and today's video is on period 3 elements and the oxides. Now, I'm thinking of creating another playlist and this will be dedicated to the content, all the topics in A-level chemistry. What I was originally thought, if I continue this video, what I originally thought was that I'd do, a video so I create a playlist for each topic and I'll just go through it as many times. But then I realized I'd have to create like 20 different playlists, which I'm fine with doing that, but it's just going to be a lot. It's going to be overwhelming for my subscribers or for my viewers who first time clicking my channel and see all of that. So I'm not really sure. I could do that. I'm still thinking about it. But anyway, a period 3 elements in the oxide is topic. So acid and base, acid plus base, salt plus water. And here's all these equations that I would recommend to memorize from the textbook. Na2O solid plus 2HCl aqueous to form 2NaCl aqueous plus H2O liquid. MgO solid plus H2SO4 aqueous to form MgSO4 aqueous plus H2O liquid. SiO2 solid plus 2NaOH aqueous to form Na2SiO3 aqueous plus H2O liquid. P4O10 solid plus 12 NaOH aqueous to form 4Na3PO4 aqueous plus 6H2O liquid. SO2 gases plus 2 NaOH aqueous to form Na2SO3 aqueous plus H2O liquid. SO3 gases plus 2 NaOH aqueous to form Na2SO4 aqueous plus H2O liquid. Amphoteric oxides neutralize acids and bases. Al2O3 solid plus 3H2SO4 aqueous to form Al2SO4 bracket 3 aqueous plus 3H2O liquid. Al2O3 solid plus 2NaOH aqueous plus 3H2O liquid to form 2NaAl bracket OH 4 aqueous. State a key fact about ionic oxides. Ionic oxides of metals contain O2 minus ions, and when they dissolve in water, the O2 minus ions accept protons from water, forming OH minus ions. So, two more equations. Na2O solid plus H2O liquid to form 2NaOH aqueous. MgO solid plus H2O liquid from MgOH squared, magnesium hydroxide aqueous. And with this one, you form a pH 12 to 14, and for the other one, you form a pH 9 to 10. State a key fact about covalent oxides of non-metals. They form acidic solutions, so ionic oxides form ionic oxides form OH minus ions, and covalent oxide non-metal form acidic solutions, strong acids, and a pH generally 0 to 2. Definition: conjugate base dissociating solution forming hydrogen ions and negative ion. Then I've got P4O10 solid plus 6H2O liquid to form 4H3PO4 aqueous. SO2 gas plus H2O liquid to form H2SO3 aqueous. SO3 liquid plus H2O liquid to form H2SO4 aqueous, and how the ions H3PO4 aqueous dissociates to 3H plus aqueous plus PO4 3 minus. H2SO4 aqueous goes to 2H plus aqueous plus SO3 2 minus aqueous. H2SO4 aqueous goes to 2H plus aqueous plus SO4 2 minus aqueous. Why is silicon dioxide insoluble in water? It's got a giant covalent structure, therefore it's insoluble in water. However, it can react with bases forming salts, therefore it is classified as acidic because it can still react with bases forming salts. Definition of aluminium oxide: partially ionic and partially covalently bonded. It is insoluble in water, but it can react with acids and bases to form salts, therefore it's called amphoteric. Even though it's partially ionic, partially covalent bonded, it is soluble in water, can react with acids and bases to form salts, therefore amphoteric. State 3 examples of metal oxides: Na2O, MgO, Al2O3. Why does Na2O, MgO, Al2O3 have high melting points? They form giant ionic lattices, therefore strong force of attraction between each ion, therefore it takes a lot of heat energy to break bonds / melt them. Why does Al2O3 have a lower melting point than you'd expect? Well, the difference in electronegativity between aluminium and oxygen is not as large as between magnesium and oxygen. Therefore, the oxygen ions in Al2O3 don't attract electrons in metal-oxygen bond as strong as in MgO, therefore partially covalent. And obviously, there's a couple more. Why does For example, MgO have a higher melting point than Na2O. Why does phosphorus, and there's a couple more on silicon dioxide, but I feel like these two are not that well by students, including myself, and maybe you guys as well. Like this one, definitely, I feel like a lot of students will struggle with it, and same with this one. Whereas the other ones about, it's just know about your structure, and for the Na2O and MgO, it's just the idea that Na2O and MgO contains the Mg2 plus ion, therefore more strongly attracted, therefore high melting point, therefore requires more Ng to break bonds. That's all you need to talk about. Now the equation 2Na solid plus a half O2 gaseous to form Na2O solid, 2Al solid plus 1.5 O2 gases to form Al2O3 solid, P4 solid plus 5O2 gases to form P4O10 solid, Mg solid plus a half O2 gases to form MgO solid, Si solid plus O2 gases to form SiO2 solid, S solid plus O2 gases to form SO2 gaseous. Then I've got 2Na solid plus 2H2O liquid to form 2NaOH aqueous plus H2 gaseous, and the pH of the sodium hydroxide is 12 to 14. What happens in this reaction? Sodium reacts vigorously with cold water, forming molten ball on surface, fizzing, producing hydrogen gas. Mg solid plus 2H2O liquid to form MgOH aqueous plus H2 gaseous at pH 9 to 10 of the magnesium hydroxide. Magnesium reacts very slowly with cold water, forming a thin coating of magnesium hydroxide on surface of metal, forms a weakly alkaline solution pH 9 to 10. Mg solid plus H2O gaseous to form MgO solid plus H2 gaseous. Magnesium reacts with steam, reacts faster with steam as more heat energy, and it forms magnesium oxide. Why is sodium more reactive than magnesium? When they react, sodium loses one negatively charged electron to form Na plus ion, whereas magnesium loses two negatively charged electrons to form Mg2 plus. It takes less energy to lose one electron than to lose two. Therefore, sodium is more reactive than magnesium. And then this is just another topic. And that's it for period 3 elements and the oxides.